Great to see you here again. My name is Luc de Kooster, founder of the Kooster Academy, and in this new video we will discuss a new distribution, a discrete probability distribution, which is the Poisson probability distribution. Let's have a look what the Poisson distribution is about. First of all, the Poisson probability distribution has some specific characteristics. It is a probability distribution for the possible outcomes of interest of a process where the average number of outcomes of interest per segment is lambda, and the following characteristics are present. First, the outcomes of interest are rare compared to the possible outcomes. 2. The number of outcomes of interest are random, and the occurrence of one outcome does not influence the chance for another outcome of interest. And a third characteristic is that the probability that an outcome of interest occurs in a given segment is the same for all segments. Now let's have a look at the formula and some example. The formula here we have P of x, the probability that x occurs, is in fact lambda times t to the power x multiplied with e to the power minus lambda times t, and all that divided by x faculty. Now x is the number of successes in the segment t. Lambda t is the expected number of successes in that segment, and e is the base of log e, or the natural logarithm, also ln, with e is approximately equal to 2.71828. Of course, there are more decimals you can add to e. When we look at an example here, in this case, lambda is the parameter describing the average occurrence per segment, like the number of failures per minute, hour, day, or month. T is the duration of a segment expressed in units compatible with lambda. Lambda t, lambda multiplied with t, are the total number of occurrences per segment. Let's say lambda is 15 failures per minute, t is 30 minutes, so lambda times t is 450 failures. We can also apply this to another example. Here we have an average number of arrivals at a counter with lambda equal to 15 customers per hour. And we see that we have a distribution with probabilities that go from arriving one client up to 31 clients. So we have this distribution where we can find the probability, for example, that 15 people are arriving. This is the highest probability. And we see that it's almost a symmetrical distribution, or it is when you look at it, but not completely. When you look deeper into it, it looks a little bit like a normal distribution. Now, when we look at this, we can also calculate the mean and the standard deviation of this probability distribution. The mean is equal to lambda times t, and the standard deviation is the square root out of lambda times t, so basically it's the square root of the average. So that was it for the Poisson probability distribution. In the next video we'll have a look how to resolve a specific problem related to taxis and waiting lines. Don't forget to click on the subscribe button, click on the bell button, and every time we have a new video, YouTube will inform you about it. Thank you very much, and bye-bye.